In continuation of carboxylic acids, now we will take up chemical properties of carboxylic acids. In the carboxylic acids, we know that in the carboxylic acid COOH group is present. So COOH, there are the different reactions in which COOH group is involved, and we categorize the reactions in 4 parts. That is, first are the reactions in which only OH bond is cleavage, means this bond cleavage takes place, that is, this bond is cleaved. And second are the reactions in which this carbon oxygen bond is cleaved, that is this reactions. And third, the reactions in which whole COOH group is involved. And last is reactions due to the alkyl group which is attached to the benzene ring. So we have reactions in which OH bond breaks, and second, carbon oxygen bond breaks, and third, the reactions in which whole carboxyl group is involved, and last is due to the alkyl group, that is group attached here, alkyl group, or it is the benzene group attached. So we have 4 categories of reactions. First is reaction in which OH bond breaks, that shows the acidic character, and acidic character we have done in detail, that is carboxylic acids are acidic in nature. The reactions which shows its acidic character are, first is reaction with blue litmus solution. When blue litmus solution is added to the carboxylic acid solution, then it turns blue into red, which indicates its acidic nature. And similarly, if these are treated with metals, that is active metals like sodium, potassium, calcium, magnesium, zinc, etc., then hydrogen gas is liberated, which again shows its acidic character. With sodium, it forms, this is replaced with sodium, and so sodium salt of acid is formed. If we take up example acetic acid, that is sodium acetate is formed and hydrogen is liberated. And similarly with calcium has 2 valency, then 2 molecules of this will react with calcium to give calcium acetate plus hydrogen. And similarly with magnesium has also valency 2, so again 2 molecules of acetic acid will react with magnesium to give magnesium acetate and hydrogen is liberated. And next are the reactions with sodium hydroxide, sodium bicarbonate, and sodium carbonate. In all of these, only hydrogen is replaced, which again indicates the acidic character of carboxylic acids. That is, with sodium hydroxide, it gives sodium acetate plus water. With sodium carbonate, these side products are carbon dioxide plus water, and with sodium bicarbonate also, side products are carbon dioxide and water. So with sodium hydroxide, carboxylic acids react to give sodium carboxylate, or say in this case sodium acetate plus water. And with sodium carbonate, 2 molecules are used to give sodium acetate and carbon dioxide plus water. With sodium bicarbonate, 1 molecule reacts to give sodium acetate plus carbon dioxide plus water. So with sodium hydroxide, sodium bicarbonate, and sodium carbonate, in all cases hydrogen is replaced with sodium. So all these reactions again show the acidic nature of carboxylic acids. So next is the reactions in which OH bond breaks, and if OH is replaced, then we get different derivatives of carboxylic acids. So we get different derivatives of carboxylic acids if the OH group is replaced. So if it is replaced with Cl, then we get the acid chlorides. If it is replaced with NH2 group, then we get acetamide and so on. So let us discuss sidewise. That is, if it is replaced with Cl, then we get acid chlorides, that is formation of acid chlorides, and it can take place with PCl5, PCl3 or SOCl2, that is thionyl chloride. So with PCl5, this is replaced with Cl, and side products are POCl3 phosphorus oxychloride and HCl. And if it is with particular example, that is acetic acid, then it is ethanoyl chloride with POCl3 plus HCl. And if we treat with PCl3, so again acid chloride is formed, and in this side product is phosphorus acid. With PCl5, side product is phosphorus oxychloride, and with PCl3, phosphorus acid is formed as a side product. So if we take example CH3COOH with PCl3, we get CH3COCl, that is ethanoyl chloride plus phosphorus acid. And with thionyl chloride, again acid chloride is formed, and side products are sulfur dioxide and HCl, which gets liberated. So this method is preferred over first two methods. And if we take example, that is instead of R, we take this phenyl group, that is benzoic acid with thionyl chloride, we get benzoyl chloride with sulfur dioxide and HCl. So with PCl5, PCl3 or with thionyl chloride, all gives acid chlorides. So next is formation of acidamides. If OH is replaced with NH2, we get acid amides. That is, if it is carboxylic acid is treated with ammonia, or with ammonia, then we get ammonium salts. That is, with ammonia, carboxylic acid with ammonia gives ammonium salts first, then acid amides. That is, if we take up example acetic acid with ammonia, then we get ammonium acetate, then acid amide, that is ethanamide. And then is formation of acid anhydrides. If OH is replaced with OCOR, then we get acid anhydrides. That is, if carboxylic acids are treated with dehydrating reagents which removes water, that is like P2O5 phosphorus pentoxide or sulfuric acid, then we get, that is phosphorus pentoxide, 2 molecules of this water is removed and all other gets attached, that is RCOOCOR, it is anhydride. So anhydrides are formed when carboxylic acid is treated with dehydrating reagents like P2O5 or H2SO4. So if we take acetic acid molecules, then again this we get water is removed, OH from here and H from here, and it is acetic anhydride. CH3CO OCOCH3, CH3CO OCOCH3. And next is, if we treat acid chloride with sodium salt of acid, then again we get anhydrides. So next is formation of esters. If OH group is replaced with OH is replaced with OCR group, then it is a ester. Formation of ester takes place, and formation of due to formation of esters, this reaction is called esterification reaction. So esterification reaction can also be asked, that is carboxylic acid when reacts with alcohol in the presence of acid, we get esters, and it is a reversible reaction. So what is esterification reaction? That is, we have also done in alcohols also. It is the when carboxylic acids react with alcohols in the presence of acid, we get ester. And the questions can be asked as, write chemical equation when acetic acid reacts with PCl5 or it reacts with PCl3 with SOCl2, or it can be asked, complete this reaction when it is this dicarboxylic acid is treated with thionyl chloride, then both OH groups are replaced with Cl, that is acid chlorides are formed. And then as third category comes in which whole COOH group is involved. Whole COOH group is involved. That is with soda lime, that is mixture of NaOH and CaO in the ratio 3:1. When reacts with carboxylic acids, we get hydrocarbons. That is, this is sodium salt of acid when reacts with sodium hydroxide and NaOH, that is, this is soda lime. Then we get alkane as a final product, that is Na2CO3. Sodium carbonate is removed and alkane is formed. R from here and hydrogen from here, so alkane is formed. If we take up example, sodium acetate plus sodium hydroxide and COH, we get CH4 methane and sodium carbonate. And similarly, decomposition of calcium salts of acids, which we have already done in aldehydes and ketones, also involve the reaction in which whole of the COOH group is involved. So next is electrolytic decarboxylation, which also involves the COOH group, carboxyl group. That is, this reaction can also be asked in naming reaction also. That is electrolysis of aqueous solution of potassium salt or sodium salt of acids undergo decarboxylation to give alkanes with double number of carbons, or we can say alkanes, and this method is called Coles electrolysis. That is, this is potassium salt of acid. When it is electrolyzed, it gives acetate ion plus potassium ion, and now at anode the anions move towards the anode, cations move towards the cathode. So anions are CH3CO negative, and this moves to anode where it loses electrons to give this acetate, which is unstable, and this further gives the alkane. Here the two carbons are present, so alkane of two carbons, ethane is formed and carbon dioxide is released. And at the cathode, cations move towards the cathode, so these cations and move towards the cathode where it gains electrons and forms potassium, which with water gives potassium hydroxide and water. So upon electrolytic decarboxylation, COOH group is removed. Decarboxylation takes place. Decarboxylation means D means removal of carboxyl group. So it involves, Coles electrolysis involves the decarboxylation, and this group is removed as a carbon dioxide. So next is reduction. In reduction, the carboxylic group is reduced to either aldehyde or ketones, or to alcohols, or to hydrocarbons. So first is reduction to alcohols, that is partial reduction with lithium aluminium hydride or hydrogen in the presence of metals, that is hydrogen, platinum or palladium, or then with chromite or diborane in the presence of tetrahydrofuran, we get RCOHs reduced to alcohols with lithium aluminium hydride, ether, or B2H6THF. If we take up example acetic acid, we get ethyl alcohol, that is ethanol. And then complete reduction to alkanes can also be done with HI in the presence of red phosphorus, that is with HI and red phosphorus at 473 Kelvin, this is reduced to this alkane, that is COH group is reduced to CH3 group. And similarly, if we take up example, acetic acid with HI at red phosphorus gives, there are two carbons, so it is ethane plus iodine plus water. So next is Hans-Diecker reaction. This is we have already done in earlier, that is in alkyl halides also. And in this silver salt of acid when treated with bromine in the presence of carbon tetrachloride as a solvent, we get alkyl halide, carbon dioxide is released, and AgBr, that is this whole OCOAG group is involved, and we get CH3Br alkyl halide plus carboxylic plus AgBr. Similarly, we take an example of silver benzoate. In this, silver halide is formed, bromobenzene is formed, and silver halide plus carbon dioxide is released. So these are the reactions in which COOH group is involved. And now the reactions in which alkyl group is involved attached to the carboxylic group. And in this we have HVZ reaction, that is Hell-Wohlhard-Jelinski reaction. This is important reaction, Hell-Wohlhard-Jelinski reaction, in which when it is treated with chlorine halogen in the presence of red phosphorus, then all the alpha hydrogens are replaced. So in this, all alpha hydrogens are replaced with halogens. This only alpha hydrogens. So these are the alpha hydrogens. These are replaced. So first is one hydrogen is replaced. If we continue the reaction, then with chlorine and presence of red phosphorus, then other hydrogen will also be replaced. If we will continue the reaction, these hydrogens are the beta hydrogens. These will not be replaced, and there will be no further reaction. So this reaction is Hell-Wohlhard-Jelinski reaction. So last is reactions involving benzene ring. As we know, the group attached to the benzene ring has a great effect on electrophilic substitution reactions. So in this, the group attached is COOH group, and this is a electron withdrawing group. So this will be meta directing group. So it is a meta directing group. In this, if we do halogenation, sulfonation or nitration, then all the new groups will be introduced at the meta position to the carboxylic group already present. So in halogenation with chlorine and ferric chloride, the chlorine group will be introduced at the meta position. So it is meta chlorobenzoic acid. Similarly, in sulfonation with sulfuric acid and sulfur trioxide, sulfonic group will be introduced at the meta position. So SO3H metasulfobenzoic acid, or it is metabenzoic sulfonic acid. It is metabenzoic sulfonic acid and sulfonic acid, phonic acid. Its spelling is PHON, then IC, sulfonic acid. So sulfonic group will be present here. So it is benzene. It is benzene sulfonic acid. Meta-benzene sulfonic acid will be formed. So similarly with nitration, nitric acid and sulfuric acid, the group will be nitro group will be introduced, and that will be at the meta position. So it is meta-nitrobenzoic acid. So this is all about the reactions, chemical properties of carboxylic acids. The first reactions in which we have done only the reactions in which OH bond breaks, and second the reactions in which OH group is replaced, and third reactions in which COOH carboxyl group is involved, and then the reactions in which alkyl group is involved, and last is reactions in which benzene group is involved. So these reactions are all connected to the earlier chapters we have done. So it's very easy topic. So we will continue further with the next topics. Thank you.